We're asked to find the normal reaction, so firstly we can draw this on the diagram. And the other forces that act on it. So acting downwards, we've got mg, and as there is friction, we also have friction. We're asked to find the normal reaction, so we need to resolve vertically. Acting upwards, we have the normal reaction. Acting upwards, we have the normal reaction, R, and that is equal to the forces acting down, which are mg, and the vertical component of the pushing force, which using trig can be found to be T sine 60. So R is equal to mg plus T sine 60. We know the mass of the block is 5, so R is equal to 5 times 9.8 plus T sine 60, which gives us R is equal to T sine 60 plus 49. Again, we're not given very much information in the question, simply told to find T. So we have to use the information we're given at the start of the question. We're told there is a coefficient of friction of 0.2 and that the block accelerates at 0.9 meters per second squared. So we can use these two pieces of information to get two equations. Firstly, using F equals ma, where F is the resultant force, we can resolve horizontally to find the resultant force, as the horizontal component acting in the direction of motion is T cos 60. And the only other force acting in the opposite direction is friction. We get T cos 60 minus friction is equal to m, which we know is 5, multiplied by the acceleration, which we know is 0.9. Now we can use F equals mu r to make a second equation, where friction is equal to mu, which we're told is 0.2, times by r, which we found in the previous part of the question to be T sine 60 plus 49. We now have two equations containing F, so I can use simultaneous equations and substitute one equation into the other to get. I can then expand the brackets. As I'm trying to find T, I'm going to move everything without a T to one side, and can now factorise T out. And now to get T by itself, I simply need to divide by my bracket. To get T equals 43.8 newtons to 3 significant figures.